Questions 21 through 25 on the 2009 Grade 8 Gauss Math Contest. The product of four different positive integers is 360. What is the maximum possible sum of these four integers? So we have four integers, a, b, c, d. Then when you multiply them together, they equal 360. And they're saying, what is the maximum possible value of a plus b plus c plus d? So I've done several of these types of questions in the past, and the key is that you want to make the number, obviously, as big as possible, but in particular, this number. You want to make that number as big as possible. So one way is to just have 1 times 360. But this only gives me two numbers. This would be the right way of doing it if the question said two different numbers, but it says 4. Okay, no problem. What I'll do is I'll just divide 360 by the smallest possible number that breaks it, and that is 2. So now I have 2 times 180. And this is great, but again, I have only 3, and I've got to have 4. Okay, no problem. What I can do is I can break that 180 again, but I can't divide it by 2, because if I did, I'd have two 2's, and I have to have 4 different numbers. So what I'm going to do is divide it by 3. And if I do, that 180 now becomes 3 times 60. And this scenario gives me my maximum value for a plus b plus c plus d. Because remember, I have to get d to be as big as possible while maintaining the conditions of the question, that is 4 different integers. And therefore, a plus b plus c plus d is 1 plus 2 plus 3 plus 60, which is 66. So number 22, the answer is B. The dollar sign is formed by drawing two parallel vertical lines through the letter S as shown. These lines cut the letter S into 7 pieces. What is the minimum total number of parallel vertical lines that are needed to cut the letter S into exactly 154 pieces? Okay, don't get intimidated. I know you think, what? 7 pieces is, I can understand, but 154. All right, so here's how you do this. Let's just talk about 7 pieces first. As you can clearly see, when you cut this dollar sign, you formed 2 pieces here. So I'll put that 2. And then the 2 cuts created 3 small pieces, one here, and one here. So I put 3 there. And then 2 pieces to the right of those parallel lines. So the pattern was 2, 3, 2. Now if I draw another parallel line, I'm just going to do it once because I think you'll be able to understand. So one more parallel line like that. If you do that, then the scenario now is, again, get 2 pieces to the left of the parallel lines, and then within the parallel lines I have 1, 2, 3, 4, 5, and 6. So each of those divisions created 3. So it's really 3 plus 3. That's 6. And then to the right of the parallel lines, again, it's just 2. So in general, it is as follows. You'll have 2 to the left of the parallel lines, 2 to the right, and in between the parallel lines, you will have 3 times n minus 1, where n is the number of parallel lines. And that's it. So all we have to do is make this equivalent to 154. So add those and make it equivalent to 154. So this is 154 is equal to 4 plus 3 times n minus 1, like that. So this becomes 150 is 3 times n minus 1, and therefore that's 50 is n minus 1, and therefore n is equal to 51. So number 22, the answer is D. In the diagram, the circle is inscribed in the square. This means that the circle and the square share points S, T, U, and V. The width of the square is exactly equal to the diameter of the circle. Rounded to the nearest tenth, what percentage of the line xy is outside the circle? All right, so basically what they're saying is, as a percentage, how much does that represent of xy? Okay, so what we will do is just give some numbers, and that should help us. And not that it's absolutely necessary, but I will draw some lines here. So to kind of illustrate, I'll draw a line top to bottom, and then sideways like those two lines. Okay, here we go. So I will label the side of the square as having a length of 2. So that means this is 1 and this is 1. And therefore this is 1 and that is 1. So xy using Pythagoras, xy squared, is equivalent to 2 squared plus 2 squared. So that's 4 plus 4, which is 8. So the root of 8 is xy. And that's not that you need to do this, but 2 root 2. Okay. So now all we have to do is to figure out this percentage, is figure out the following. It would be xy minus this segment, which is essentially the diameter of the circle, all over xy. Right? Because if we take xy and subtract from it the diameter, that will give us those two pieces. And that's what they want. They want you to figure out those two pieces divided by the full xy. That is the percentage that they're interested in. Okay, this is no problem. Xy we just figured out was 2 root 2. The diameter, they actually tell you the diameter in the question, that the diameter of the circle is the same as the width of the square. And the width of the square I have called 2. So that's 2. And xy 2 root 2. So get out your calculator. And this is approximately 0.82 over 2.82. And as a decimal, that's 0.293. And as a percentage, that's 29.3%. And that would be choice A. Starting at point P, Brina constructs a straight-sided spiral so that all angles are 90. After starting with the line segment of 1, each side is 1 longer than the previous side. After completing the side with length 21, Brina's distance from her original starting point P will be between. All right, so let's draw this out. I really don't see any actual shortcut other than drawing it out. And drawing it out is not that painful because we only have to go up to 21. And there we go. And definitely not drawn to scale, but that's okay. Now I'm going to label these. And in the question, they had actually labeled the first few. So I'll label all of them. It just increases by 1 every time. So 1, 2, 3, 4, and so on, all the way up to 21. And what they want is you to figure out the distance from that point all the way to the starting point, which was obviously at the very beginning. That is the distance they want. Okay, so how do you do that? Well, obviously, you're going to use Pythagoras. So what I'll do is I'll initially just draw in that line that's going to make a triangle. So that's going to be right here. And that's going to be a right triangle, obviously. So if I can figure out the distance from here to here, and then the distance from there to there, I can use Pythagoras to figure out my distance that I've drawn in red. I'll call that D. Okay, so this is just, there's no trick here. This is just basic counting. So I'll show you how. From here to here is 1, right? And from here to here is 3. So that means that from here to here is 2. Okay, so I hope that makes sense. That's all it is. There's no trick here. And then in a very similar way, if from here to here is 5, and from here to here is 7, and that means that from here to here is 2. So right there, that's 2. Okay? And you just keep going like this. I'll just do a couple more. If this whole thing is 9 and this whole thing is 11, then that means that from here to here is 2. So that means from there to there is 2. And in a very similar way, you can figure out that this is 2 and this is 2. So when you add up these guys, it basically gives you this distance, top to bottom there. So it's 2, 2, 2, 2, 2, and that's 10. So from here to here is 10. And since this whole thing is 21, that means from here to here is 21 minus 10, which is 11. So there you go. We just got the first of the 2 sides. And in a very similar way, I use a different color. We have to figure out that distance, and we do the same thing. Let's see here. From here to here is 4, and from here to here is 2. That means this distance is 2. Correct? And in a very similar way, from here to here is 8. From there to there is 6. So that means this distance is 2. And you can do the same thing to get 2 here, 2 here, and 2 here. So this whole distance from there to there is 10. So there we go. We just got the dimensions of that triangle. So d, using Pythagoras, d squared, will be 11 squared plus 10 squared. And that is, let's see here, 221. And therefore, d, if you take the square root, is approximately 14.8. And therefore, that would be between B here, 14 and 15, for number 24. A list of 6 positive integers p, q, r, s, t, u satisfy that p is less than q, less than r, less than s, less than t, less than u. There are exactly 15 pairs of numbers that can be formed by choosing 2 different numbers from this list. The sums of these 15 pairs are as follows. Which sum equals r plus s? Well, our 15 pairs, we can write them out pretty quickly. P plus q, p plus r, p plus s, p plus t, and p plus u. And then q plus p does not need to be written out because that's only counted once. So we just have to write unique pairs. Q plus r, q plus s, q plus t, and q plus u. And you keep going like this. There's only a few left. R plus s, r plus t, r plus u. And the last 3, s plus t, s plus u, and the last one, which is t plus u. Now, what I initially thought, which is not correct, is that this is all in sort of order. So, for example, this is 25, this is 30, this is 38, and so on, right? And that is tempting because you think, oh, I can do this really quickly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I just have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, r plus s is 76. Circle that and move on. But that's not the right way of doing it. I know that is very tempting to do, and I initially thought about doing that, but then I quickly realized, no, that's not going to be the case. What you do is you add up all of these. And when you do, it's actually pretty straightforward. It's just 5p plus 5q plus 5r plus 5s plus 5t plus 5u. And when you add up those, they all have to equal that, right? Because we don't know the order, but we know that all of these guys represented by those guys. We don't know which one is which, but the sum will be the same. And when you do add up all these guys, it's pretty straightforward math. It's 980. Now, if you factor out a 5 from each of these, you get just p plus q plus r plus s plus t plus u, right? And then if you divide through, you get that this will be equal to 196. All right, so now where do we go? Well, at this point, there is some good news that the smallest possible is going to be P plus Q. The rest, in the middle, we're not sure. But the smallest must be 25, right? And similarly, the largest is also something that we can be assured is T plus U. So the largest must be 117, this guy right here. So this was the smallest, this is the largest. The other ones, I'm not sure, they might overlap a little bit. So that means if you go back to this and this, we can substitute in 25 for P plus Q and 117 for T plus U. And that will give me R plus S is equal to 196 minus 25 minus 117. And therefore R plus S is equal to 54. So as you can see, it was not 76 as I had previously, thought. It's actually 54. And therefore number 25, the answer is B.